faster models are smarter models. I think that is true. Trivially, you can imagine that even if the model's not super capable, but it does one thing extremely well, like the faster it can do that, the better. Anytime I know exactly what I want, and I'm confident that I can communicate it explicitly and neatly, and I just need that thing done exactly, Codex is my guy. And anytime I need the model to understand what I mean, then I use Claude Code. Why would you use a model that's 90% as good as a different model?
Yeah.
If you have to do one thing with the model. If I need the model to change the color of that token from blue to red, you know, I don't care if it can count to 10.
Yeah.
I care it does that the best in the world. But we do want to make sure the model has that smooth frontier, right? In the situations we know the model is going to be in. It's correct to say that ultimately we'll wind up with.
Hello and welcome everyone to another episode of The Merge, the podcast we bring to you here live from the CodeRabbit Office in San Francisco. My name is Hendrik, I'm a developer advocate here, and today I'm joined by Chris, Alexios, product research engineer at NVIDIA, and many more things and professions Chris does, which we're going to learn about in a minute. So super excited to have him here. Chris, how are you doing today? It's been a busy week for you.
Yeah, man, it's been good. It's been a little bit of a crazy week, obviously. But overall, it's been really exciting. Sorry, my voice is a little bit shot. We had some celebration last night with the team, so a little bit scratchy this morning. But it's GTC. It's the Woodstock or the Super Bowl, depending on who you ask, of AI. And it's just such a pleasure to meet all of the incredible developers that get to come to the conference. And it's been a blast, a whirlwind, but a blast.
Yeah, I was there yesterday, and I think the atmosphere, even though it was the last day of the conference, was incredible.
I think too, like GDC is a lot of things to a lot of people. And I think, but first and foremost, at least, you know, from my perspective, like it is a developer conference. I think there are not as many of those these days. There's a lot of like kind of enterprise conferences. There's a lot of like research conferences, but there are fewer conferences that are like dedicated to sharing knowledge with people who are building with tools or building tools. And so, you know, even on the last day, which is like our workshop day, you know, people are learning all day how to build cool stuff, and the atmosphere doesn't really die down until we force it to. So, you know, it's like we gotta shut the doors at some point, and that's about what kills the vibe.
Yeah, that's true. I remember you had to force people to leave the premises.
Yes.
Yeah. Great. We can talk a bit more about NVIDIA and GTC in just a moment, but maybe for people who are watching this who haven't heard about you yet, can you give us a little bit of an intro about yourself, your career path, and how did you end up here? I
just like building stuff. I've always liked to build stuff. And that's basically my whole career path has just been like building stuff and then yapping about it. And then just take that to its logical extreme. I think, you know, I have a non-traditional education background, so I don't have a master's or PhD. You know, not self-taught by any means, taught by very incredible people along the years, but you know, and then got kind of into the startup game a little bit. Did some work as a data scientist, which is you know, obviously machine learning is the absolute best. Learned that lesson very early in a computational physics class when I attended Trent University. So, you know, just been cooking ever since. After the startup game, on the kind of side of the startup, you know, thing, I was doing some YouTube videos and things like that, trying to bring the technology that I love and know is important to as many people as possible. And that's when I interviewed at NVIDIA, and here we are. A few years later.
I think I watched some of your content, and I watched a little bit of your trajectory as well. I think it's really amazing. If you check out one of Chris's videos, you see the passion that really goes into what the concepts that you explain. Can you tell me a little bit about how that passion, you know, started first?
I think it's the word that that people most use to describe me, which is not the word that I would have thought it was when I was like younger, right? Which is that I'm a very passionate guy. I think very excitable person. I'm very obsessive about the topics that I'm interested in. And so, you know, when discussing those topics, I lead with all of my energy, right? So I think because of that, it kind of keeps driving me forward. to continue to like either write about, these topics or to talk about them. But so I was in uni the first time that I heard about machine learning. And it was like this idea that you could write programs that did stuff based on rules. Obvious. That's great. That had been great my whole life. I really loved that, in fact, right? Like I was in like a code camp when I was like 6 or whatever at university. Shout out University of Manitoba, with my grandparents taking me every day. But then suddenly you learn like, well, we don't actually need to write the program, right? We need to set kind of some conditions and then get a big pile of data. And then we can figure the program out over the course of training. And that really just like expanded my mind like 700 times, right? This idea that we don't need to write the rules. We can learn the rules, right? And I built a really dumb project. And I recommend this to everybody. Like my buddy had a bird. And we used to play League of Legends together. And we would be on Skype with each other so we could communicate. And I loved the bird. Okay. It was a cute little, I don't know, like a parakeet, or budgie or something like that. The little bird. And I wanted to see the bird whenever it was on camera. But my buddy wouldn't always remember to tell me. So I hooked up a vision language to my webcam called BirdBot that would notify me when the bird was in frame. Right.
Oh, wow.
It was so dumb. Right. But like it got me using TensorFlow at that time. And this is like old TensorFlow. It was like really rough. And then from that, you immediately can see like a world of possibilities unfold before you, right? Like, what if we could do this better and faster? And what if it wasn't like a bird, but it was, something more interesting? But like that is kind of what set the spark to push me down the path that got me to where I am now.
I think that's really interesting because, you also then participated in other ventures like the AI makerspace and took that passion to these type of avenues. Plus then also, of course, telling more people about how to use LLMs, how do they actually work under the hood, which I think is amazing. So that curiosity really took you a long path.
Yeah, I have like a very specific mission in mind when I'm whenever I talk about something about machine learning or now what we call AI, which is like, I think that the people we need in the world to actually help us with artificial intelligence, like don't know what it is yet. And there are loads of curious and smart people who have a wealth of knowledge, right? That we just haven't like rolled in yet, right? And you see this all the time in any kind of like AI research where it's like, oh, this idea from this random field from the 1950s has like made our models better, right? And I think that because I believe this to be true, it makes it really easy to want to talk about it to everybody and to reach as many people with 100 level, 200 level knowledge so that they can kind of, have the same experience I did with BirdBot, where it's like, oh, like I could apply this thing that I know to this system and like maybe it would work. And then they try it and usually it does work. Right. So that just keeps me motivated to want to like yap about it all the time and teach as many people as I'm allowed to teach, what this technology is and how to use it so that we can get the advancements that I think are critical for us to move forward in the field.
What kind of advancements do you think are most critical?
We have to make models faster. We have to make systems that sit around models more capable and hopefully leverage techniques that we've picked up from like cognitive sciences and like especially when we talk about things like memory for models, right? Or for agents more specifically. I think, we have this idea that like agents are models in a loop that do stuff. And we have like the most basic form of memory, which is like context window. And now we kind of like are expanding it a little bit, but I'm certain that's not the most optimal approach, right? Like our current memory systems are far from optimal. And so we need better ones. The faster the model can run, the better it is. I'll say the line because I believe it in my heart of hearts, which is like faster models are smarter models. I think that is true. Trivially, you can imagine that even if the model is not super capable, but it does one thing extremely well, like the faster it can do that, the better. And then also like, talking about content safety. So security is like a different thing. We need lots of security experts. They're cooking. They're doing their jobs. Like content safety is really important. These models are producing a lot of tokens. And those tokens are seen by a lot of people. And like the safer that content is, and the better aligned that content is to our respective values, be they, American, since we're in America right now, or Canadian when I'm back home, or whatever other sovereign nation, right? I think that those kinds of efforts are extremely important to nail down. Like I don't want every model to be the same. I want it to reflect the people that will use it and reflect the people that made it.
I want to put a small pin on something that you said before as well. When I was going through some of your previous work, I saw that you also published at least some hot takes or some guide-facing pieces about things like context engineering, and then the thought piece from the evolution from prompt engineering there. We obviously here at CodeRabbit care a lot about context engineering as well. So I'm kind of curious to hear your thought process on the...
All we've been doing the whole time is context engineering, right? We just like finally put a word on it. I think all of these... It's a really interesting thing to have been in the space long enough to kind of go from like when we thought LSTMs were good all the way to now that, we're very deep in not just like transformer architecture, but kind of like cursed transformer architecture, right? Like the hybrid models, we're actually like really playing around with it. But like we've always been doing context engineering, right? Like whenever the prompt engineering boom, right, happened and people were like getting paid 6 figures to do prompt engineering, right? That's just context engineering. We just finally got a good umbrella term because someone came up with a smart word for it. But that's all it is. Right? It's like everything is context engineering because everything is context. The model has a context window. That's how it sees the whole universe, right? Like that's the only thing that the model has to interact with the world is the context window. And so it's all context engineering all the way down.
I think you named it as the first class infrastructure before. So what do you see, or how do you see, for example, some of NVIDIA's customers deploying that idea successfully in production? What do you think is most important? If I'm a builder listening to you right now, yapping about context engineering, what is, what's your best practice advice?
The reality is, and it's like kind of a cop-out answer, but I think it's the real answer, which is you have to learn the model. And that means like playing with the models. So I know it's not like technical advice and it's a little bit cringe, but the reality is you have to put the model in whatever system you're trying to use it in and like just play around, learn the experience of the model. Back in the day, like I think we've gone through waves of this, and I've personally gone through waves of this of like, well, prompt engineering like is just kind of vibes based. It's not really engineering, and what I'm suggesting now is kind of vibes based. It's not really engineering, but like, it's going to help you engineer something when you need to, right? Like if you understand how the model works or how it reacts to like specific changes in the prompt or changes in like how you define tools or changes in whatever it happens to be they're working with, right? The memory system, like you add some kind of like time weighting to it and you feel the experience, of that system. It's going to help you make actual engineering choices in the future. And so that's got to be the step number one. I feel like a lot of people build systems and like they don't just use them like themselves to build that intuition. And as models get more and more complex and can do more and more things, I think it's like it becomes more important because all we're going to have is intuition. I've met you, right? There's no way for me to engineer you. You know what I mean? Like there's no way to engineer a human being to do exactly what you want. You can like work with someone, right, to understand how they tick and like, know how best to interact with them and know the best way to make an ask and this kind of thing. But like, there's not like a set of explicit instructions that you can use every time that like lets you just get humans to do what you want. And I think we're entering the same point with models where it is very intuition based. And another good practice thing though is like you should be leveraging search for context engineering systems. This includes for memory. We want to limit what we shove in context. There's like a business term that's as much as needed as little as possible. I think for context engineering, that's still true. We should have exactly only the tokens that we need and exactly no more or no less than that. And so every decision you make should keep that in mind. We don't want to just, as tempting as it is, we don't want to just dump everything in context and pray.
Yeah, that makes a lot of sense. Let me dig a little bit deeper because I also found you in one of your AI Maker Speakers talk. You talked about, RAG being necessary, retrieval augmented generation being necessary, which often is tied to like a vector database. Yeah. You do semantic search and you optimize obviously for either putting in context that is not part of the training data or finding, other more relevant results. But then there's also famous examples, like for example, Claude Code, where Boris the creator stated on X, for example, that publicly we know that they're not using a vector database behind Claude Code. So what is your argument?
I have the greatest cop-out answer in the world here. So we've always been very clear, especially in my work at AI Makerspace, of this idea of like there are foundational patterns in AI engineering, or what we used to call like machine learning engineering. And one of those patterns is retrieval augmented generation. And while it's true that when people hear, because of a lot of really fantastic marketing, when people hear retrieval augmented generation, there is the assumption that there's a vector database or some other, maybe a sparse vector retrieval pipeline, whatever it happens to be, right? But the reality is like, is the pattern of retrieving something and then using that to augment our context window in order to generate a response.
There's no name vector in RAG, right?
Yeah, yeah, exactly. Yeah, it's just such a powerful pattern. And I think we need to, as a field, like focus more on the foundational patterns as opposed to the specific technological implementation of the patterns, because we get kind of locked into a mindset when you say RAG and everyone assumes you mean. I mean, if you look at the original RAG paper, like the image people conjure into their minds when you say RAG like is not the same as that paper even, right? And I think that's the thing. And if you use grep with an agent to get context to put it into the context window to generate a great response, like you can make yourself, you can convince yourself you're not doing RAG, or you can convince yourself you are doing RAG. But certainly the pattern that you're applying is fundamentally a very, very useful and very, very powerful one.
So where would you say that a vector or the usage of a vector database is still meaningful?
Listen, we have petabytes, exabytes, whatever it is, of structured data. We have a lot of situations, especially in big enterprises, but not exclusive to them. Like getting a document that's pretty close to what you said is useful. Vector databases, while they may not be the best tool for all cases, and there are even good arguments to say that they're suboptimal in a lot of cases now. There's still usage that is important with vector databases. Some of the issue of vector, like dense vector retrieval, is that it's kind of slow. QVS, obviously, yeah, I'm wearing like 2 NVIDIA shirts right now, right? So QVS is like GPU accelerated vector search. I think like that helps smoothen some edges out. If someone were to ask me, I have like 10,000 PDFs and I want to build a chatbot, I'm almost certainly still saying like, yeah, hook it up to whatever vector database and have that be the place that you start. And then if that's insufficient, you should start reaching for more complicated tools.
Interesting, because there was so much engineering that went into tools like, for example, Cursor, that built very complicated retrieval systems, Merkle trees, and all kinds of algorithms to improve their vector search, because they're using something like Puffer. Right. And then you have a tool like Claude Code taking the market at a sweep. And now these days, most serious developers that I know are using Claude Code and they're not using Cursor anymore. Why do you think that is?
I can't really speak to what other people think, but I'll tell you what I think, which is that these tools, especially right now, really come down to like a vibe, which is that like, do you like the vibe of the tool? And it is the case that, different strokes for different folks kind of thing here. But the idea is like something like Cursor, at least to me, is still a useful tool, especially, by the way, for like anything to do with the Jupyter Notebook, which is if you're in the space of like creating technical assets that you want people to learn from. Still a really important like format to deliver those technical assets. And like Cursor rips pretty hard on notebooks.
Yeah.
But like it comes down to the vibe and the ergonomics of the tool. One of the things that we saw, I know you guys have been some of the biggest observers of this phenomenon, is like it's, I think, more lightweight to spin up 8 instances of Claude Code to rip through a bunch of work than it is to set up 8 instances of Cursor and do the same thing. But Cursor's got a CLI now, so you can still do that. That's like the idea. It's a vibe. Like, do you like it? For me, I like basically every tool because they all are good at different things. It's less than it used to be clear, but there are projects where like I do want to be in the IDE with the code while the agents are tearing away at it. But there's a time for each tool, especially when it comes to something like Claude Code versus Codex, right? Like there's a, like if I'm looking at a problem, I can tell within the first like 2 or 3 minutes is this going to be a Codex situation or a Claude Code situation, right? So
Which one's which?
Anytime I know exactly what I want, and I'm confident that I can communicate it explicitly and neatly, and I just need that thing done exactly, Codex is my guy. And anytime I need the model to understand what I mean, then I use Claude Code. You know what I mean? I don't know what it is, but Claude as a model is just super good at knowing what you mean. It's great at determining intent in a way that for me resolves to the correct intent. And though I am saying like Codex and Claude Code, obviously like open code or kilo code or whatever, it doesn't matter. Whatever shell you use, whatever TUI you use, I think is less important than the vibe of that TUI, so you can apply it to the right problem.
What does your setup look like at home when you're tackling one?
Hot take here. Okay. The greatest invention of the modern age is not Claude Code or Codex or, these PhD level models or whatever. It's tiling window managers where you can just like neatly tile all of your Claude Code instances or Codex and whatever tool you use, right? Like that has been a godsend.
I completely agree. I love it.
Yeah. There was like a week before, because I'm this is a little bit cursed, but like I'm primarily on a Windows machine for my developer station, and then I SSH into like the computers that do work, right? But I just like the Windows ecosystem for everything else, and so it's like a little bit of a pain to get a tiling window manager to work well for Windows, but you can do it, and you should do it, by the way. And yeah, so it's like I have 2 vertical monitors and then 2 horizontal monitors, and I just fill them up with squares of whatever coding agent I need for the problem. And hopefully at the end of the day, I shut at least some of them down, but not a lot. Tmux is also your best friend.
That's great advice. Thanks for sharing that. Let's switch gears a little bit.
Sure.
Let's talk a bit about your work at NVIDIA. I think people are interested to know what exactly are you working on?
Yeah, so I'm a product research engineer, which is like a fun title because it's just 3 different like functions in a row. Like it's not very self-descriptive. A big component of my job is like traditional developer advocacy. That's something that I'm very happy to be able to do, and something I know you're familiar with. Which is that like devs are really important. Devs are also not like a monolith. There are many different kinds of developers, and we want to make sure we're talking to devs to understand like what is their experience using our products, what is their experience with our ecosystem, so that when we're making a decision, someone in the room can speak for them, right? And that's something I take extremely seriously, and I'm very, very lucky that it gets to be part of my job, right? Saying, this feature is great, but like no one cares about that, or like this feature is great, and like people have been demanding it for the last month or 4 months, right? Just making sure that devs feel like they have a voice in the company that speaks or is able to speak on their behalf at least a little bit. I work with the Nemotron team very closely to help make sure that our models are good, which is a overloaded term. I get the opportunity to like help them, but they are the masterminds and the orchestrators and the implementers. So one like fun meme way I like to describe the role of product research engineering is that to product, I'm a research engineer. To engineering, I'm a product research guy. And then to research, I'm a product engineer, right? So the reality is that I just synthesize between a lot of extremely talented groups of people to try to tell a story across the whole technology stack.
I mean, that sounds like a very fulfilling role, to be honest.
Oh yeah, it is. It's super fire. Yeah. I don't know how I got into this or lucked into that role. It's quite literally, at least for me, like the perfect role. So, and they let me do stuff like this for whatever reason. So there you go.
I think they've chosen well.
Oh, thanks.
Yeah. Tell us a bit more about Nemotron, the family, the model. What's special about it?
Yeah.
Architecture. Yeah.
I've been a big fan of Nemotron since I joined NVIDIA, even very slightly before I joined NVIDIA. Nemotron's actually like been around for a long time. I think people just like have not cared a lot about it until recently. And this is not because the models weren't good, but I think it's because we just didn't really know how to talk about the fact that we were trying to build models. Like, there's a conception or a perception, sorry, that NVIDIA is just a hardware company. I mean, it is a hardware company, and at the end of the day, that hardware is the most important thing that we do. But to make the best hardware, you have to also make really, really good software, right? And this is not just because like it's good to make good software, though it is. It's so that when you're testing your hardware, you have the conditions that allow you to explore what the limits of that hardware is, right? So Jensen, the CEO, always talks about this idea of extreme co-design, which is that you build a chip, and then you use that chip to train a model. And then in training that model, you're going to learn a ton about what that chip can do, and then maybe where it needs to change or improve. And then you can bring those learnings to the next layer of the stack, right? Recently, we've been talking about this thing called the five layer cake that is AI. Look up the article if you want to learn more. But the idea is we need to go from in these cycles from metal all the way to end user, from metal all the way to end user, in order to design the best, most efficient, most powerful hardware. So all of that to say, that's why Nemotron. We had Nemotron. It was doing good numbers. It was actually quite a good model for synthetic data generation. The first Nemotron I got the chance to work on was a 340 billion parameter model. At that time, was so huge, right? A dense model, by the way. So like it's just a big guy. And then I think, we got a little bit better about talking about it. We got a little bit better about understanding what people were using models for and communicating what the message is, which is this idea of extreme co-design and this idea that faster models are smarter models. And our researchers have just been cooking like you would not believe to make these models go faster and even faster, and utilizing Blackwell to do cool things like NVF before pre-train. And what Nemotron is now is a family of models. So we're currently Nemotron 3. Nano we released a while ago. Super we just released. And Jensen just talked about Ultra finishing pre-training. We had some numbers up. It's doing very well for a pre-trained model. Do you want to be very clear to anyone watching? You see numbers from the keynote about Ultra. Keep in mind that is just the pre-training. So it's not a finished model. So it's not going to have good results compared to something like Kimi K2.5, which is a fully trained model, right? We are just looking at the pre-training base model before all of the post-training stack, which is an incredibly important part of training model.
Explain a bit more why this part is so important.
Yeah, I mean, the idea is like the base model needs to be good, but it isn't really good at the stuff that you're familiar with a model being good at, right? It's not good at following instructions. It's not super good at calling tools. It's all of these things are things that we teach the model how to become very good at during post-training. And the idea is, we need a really good base model. So we need a good foundation to build a great model on top of. And we want to make a really good base model that's open, and that's why we've released the base checkpoint for Nano and Super as well, right? Because if you want to build your own model, pre-training is like the most expensive part. It takes the longest. It is extremely resource intensive, right? And then the post-training stack is not. It's certainly not inexpensive, but it is more affordable than pre-training. So we want to have a base that people can train whatever their favorite model is.
Right.
But what happens is that when people hear there's a new model, they think like, oh, this is going to be like better than Kimi. And it's just like, well, let the post-training team finish their jobs. For now, it's just the base model. It's like the lump of clay that you can mold into whatever you want, but it's really high quality clay. Yeah.
No, that's great. You also did a lot of work, or at least you published quite a few opinions on LLM evaluation.
Oh yeah.
NVIDIA. Yeah.
Yeah, man. It's not a good time out there right now. Evals are super hard. How do you evaluate a human being, right? Like it's very hard. It's so hard that we've been trying to do it for as long as there have been human beings, which by my calculations, like quite a long time, right? Yeah. In fact, for as long as we've been around.
Yeah.
And I'm not trying to say that models are human beings, but what I am trying to say is that as models gain more and more intelligence and their capabilities become closer and closer to, the kinds of capabilities that you would expect a person to have, it gets proportionally more complex to then evaluate them, because what does a good model look like when there's some stuff that, like, of course it's just going to be able to do. So how do we really like determine, how do we fill in all the gaps? I like this idea of like benchmarks are tent poles. Okay. If you imagine this, what we would love is for our models to have a really like a flat capability frontier, right? So no matter where I poke the model, it's as good as it is in everything else. So like my coding model, when I poke the coding ability, I want to see the number be high. And then I want the math ability to also be high. And I want the chemistry ability, and I want the legal ability, and I want the blah, 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 right? But in reality, models have to be trained on stuff. And so we have a very jagged capability frontier, right? Where the model is like maybe great at coding and great at math, and then is not so good at like writing, writing a story, right? Or like making beautiful poetry or whatever it happens to be. And so we need tent poles, right, to prop that up. We need both a good way to train it and like any way at all to evaluate what is a beautiful poem, right? Like,
I mean, we have opinions about that here at CodeRabbit, as you know.
I bet you guys do.
I have a contrarian thought. There's a lot of opinions on the internet, and rightfully so, I think, in the community as well, that we should not be optimizing for a horizontal, capabilities curve, as you just described it. Yeah. We should be training specialists in each category.
If you need the model to be good at one thing, you should certainly train it to be good at that thing. I think, though, we don't want that. A lot of people want, not just because it reduces deployment complexity or whatever happens to be, but because they want the same. They want to have confidence in the model in whatever task they apply it to, which is why even if Team Green's published a lot of papers on like the future looks like a bunch of specialized swarms of agents, right? Even if that's true, we still want to know how to train like the perfect generalist. Not AGI. A lot of people at the company have said, and I'm sure we'll continue to say, like, we're not worried about AGI. That's like whatever. That's a good side effect one day if it even is defined well. Yeah. But we do want to make sure the model has that smooth frontier, right? In the situations we know the model is going to be in, that the capability frontier is smooth. But I think it's correct to say that ultimately we'll wind up with specialist models. We have to, right? Like, why would you use a model that's 90% as good as a different model? Yeah. If you have to do one thing with the model. If I need the model to change the color of that token from blue to red, I don't care if it can count to 10. Yeah. I care it does that the best in the world, right? So, yeah.
I mean, there's also maybe something that people could get confused is with it. If you look, for example, at the architecture of Nemotron, you have this mixture of experts architecture. How is that different from training a special model, having the mixture of experts already baked into the larger model?
I would think about it this way, where MOE is a really good efficiency tool. It also gives us like this really good capability to like borrow experts, right, for unseen tasks. So if I have like experts that are really good at a set of things, and I'm doing something slightly out of distribution, I might be able to like borrow from another expert's expertise, right, to get the task done. But at the end of the day, it is a unit of model that is good at a set of tasks. And so you have to train it like a generalist, even if in function it can behave like a specialist, or perhaps like specific per query experience of the model is more specialist in nature. What we hope is true with specialist models is that they can be smaller than the generalist model, right? So that we don't need as many parameters to be as good at one task as we do to be good at 5,000 tasks. And so that's the advantage of the specialist. I hope at the limit is that they're just significantly faster than the generalist. And if you only need to be good at 10 tasks, despite deployment complexities, it might still be better to use 10 specialists rather than one generalist.
Yeah, let's talk about deployment and deployment complexity for a minute. I think a lot of people are hoping as models get smarter that we can have them deployed more locally on hardware devices, right? Maybe even phones soon. Where do you see that going? I
mean, I'm a big believer, man. So, I don't think it's a hot take. I think that is the future. I don't think we've even begun scratching the surface of how small and efficient and compact and wonderful we can make these models. I really believe that we've seen this already. If I were to have you chat with ChatGPT on day 0, right? Like, it gives off the vibe of like our like kiddie models that we can train in an afternoon, right? Like literally Carpathia's speed running, GPT-2 level models in less than like 3 hours, right? Like, I haven't checked the leaderboard in a bit, so I don't know if he's cracked sub 2, but the idea is like, we are going to make models better, and we're also going to be able to pack more capability into smaller packages. I do not think we're anywhere close to like a theoretical limit on that yet. I do. Listen, there's some concessions to reality and physics that you have to make. Like, we can't make. It's unlikely even in time that we're going to make a GPT 5.4 in pro mode level experience available in sub 100 milliseconds on your cell phone, you know. But most certainly, I believe strongly that we'll continue to make models smaller, and that in 2 years we'll look back on, some of these models and be like, I cannot believe you can whip those up in an afternoon now, right? So, and certainly NVIDIA is dedicated to this mission.
Yeah.
We have incredible quantization teams. We have incredible, doing really cool stuff like the Cascade models, doing really cool stuff like all of the teams that are working on trying to train the smallest, most capable models like Nano. The smallest of the Nanos dropped this week for even more edge device, experiences. So, yeah, strong believer that we will continue to make smaller models better and faster.
What do you think about the training challenges that we're having? I think you spend a fair amount of time, generating synthetic data for training, doing a fair lot of RL, reinforcement learning. Some people have made points that we run out of data and that synthetic data will not be enough to unlock the next frontier, that we might even need to change the transformer architecture. Where do you stand on that discussion?
Listen, here's the reality. At NeurIPS, Ilya, of course, famously said that data is a fossil fuel, right? That we're going to run out of data and all this other thing. I think SDG at this point is all but proven to be like the renewable energy equivalent. We can SDG our way out of a lot of.
What does SDG mean?
Synthetic data generation. Sorry,
okay.
Hitting you up with the 3-letter acronyms. It's a bad habit. But synthetic data is able to really cover a lot of the cases that we need. Now, is that to say, to the broader point of your question, no, I don't think we need to change the architecture to accommodate this. I don't think we need to worry we're going to run out of data, but certainly we're going to change the architecture. Because there's no way this is the best, right? There's no way we got it exactly right on our first try. In all of human history, I think we've done that like 6 times. You know what I mean? Like, we are going to continue to iterate no matter what. Even Nemotron iterates a lot each generation, like a lot, in terms of the core architecture of the model. I don't think we're done. And it's going to help us with data efficiency. And it's going to help us, bridge some of these gaps people are worried about. But certainly I don't think we need to. We just will. We're humans. You know what I mean? We even when we get to what might be literally the most optimal model, I'm sure we will keep customizing for hyper specific niche situations, right? So
what do you think about the observability concern, trust, and governance as well as responsible AI? Is that something you have on your mind as well?
I'm so privileged to work at NVIDIA for this question, right? Like we open source almost every token. We care deeply about security and safety. We write about it a lot. You can look at the data that trains the models to determine if it meets your safety thresholds or what have you. Do I think it's literally perfect? No. So there's work to be done. But when it comes to things like data lineage, when it comes to things like understanding what went into the model, which helps assuage some of the concerns that you're bringing up. Just so lucky to be working at Team Green, where we're open sourcing a lot of this, so you get to make the decision, right? I can only speak for me, right? In my opinion on this, but like I don't want to make that decision for people. You know, like trust me, bro, is not a strategy. You know, like if you want trust, you should be transparent and allow people to look through and trust you because you're trusted, right? Like. I think that's something that is so lovely about the culture at the company that I'm happy to work at, which is that everyone wants to be transparent and show people exactly what we're doing, show people exactly how we're improving, right? Show people exactly what fixes we have made to address concerns, and we have a whole safety stack and a whole security stack that, of course, the teams that work on those things are, you know, they're doing incredible work. I'm super proud to be able to point to them and their work to say like we have some of the most transparent models that exist right now, and it just does a lot when you're trying to do something in a way that garners trust. So
aside of NVIDIA, and I mean this is great work that you're doing there for Nemotron and the family and all other open source models. I think the main concern that people have, and we talked about AGI before already, right, is that the agentic systems that we build with these models have inherent biases that might even be manufactured for, you know, or not for the best for humanity or society. Are you concerned?
I'm not a doomer.
Yeah.
I'm not like a hyper accelerationist or whatever. You know what I mean? Like I'm a Canadian guy, so I'm comfortable living in the nebulous space that is neither a specific camp. I don't feel like I have to make a choice one way or the other. What I'll say is that, of course, there are things about, bias that concern me. One of the things that I am concerned the most about is that it can be very difficult to detect bias, and it can be very difficult to know when you are being biased. And the using models that have biases are going to leak into the way that people think. And I think that potentially could have long-term impacts when it comes to 0.001% bias over one interaction is like nothing, but over like 10 million interactions is like a lot, right? And so it's just kind of like, I'm not like worried about it in an existential, keeping me up at night way. I do think it's important to continue to think about it and continue to mitigate. And that's a beautiful thing. Again, just to pull the Team Green privilege card here, like that's the beautiful thing about building open models is that all of the people that I think need to help are able to. Even if what you can do is look at data and say, here exists some bias, let me help you solve it. Like that's hugely impactful and influential, right? Am I worried that every private company has everyone's best interests at heart at all times? Again, not in an existential way, but I think in the long run, even those companies are incentivized to build models that help humanity and that make us better. So I believe that at the limit, we're going to have models that help us and make us better.
Yeah. Let's broaden the scope a little bit because we talked a lot about open source models. Most of the open source models currently are coming from China. Most of them. Yeah. What do you think about the manufacturers that or like the models per se that are coming from there? Which model maybe surprised you the most? Which ones do you deem most capable? And how do you compare them to, for example, the Nemotron family?
I think the benchmark numbers are the easiest way to know how they compare on like a capability front. sovereign AI is something that's important. Countries should be building AI systems. We're working with countries like India and Korea and a bunch of others. So that China is also building good models is something that you just have to expect, right?
Yeah.
The most surprising one probably is like Timmy K2.5. It just makes like really good websites. It has like better taste than some of even the frontier models. Like I think if I were to tell you like a Claude Code web template, like I think most people would kind of, if you've used something like the Claude models to build websites, will know what I mean. Like it has like a kind of samey feeling like structure and theme to it. Kimmy K 2.5 kind of like, it's not always super different, but like it generally builds very like novel websites for each different use case. And that's something that I think is, it's not like, listen, it's not the most important thing in the world.
Yeah.
But like, it's nice that the models are like developing some taste. You know what I mean? Like that was
I would
surprising.
love that. I would love to try it out, actually. I mean, I tried Kimmy K 2.5. I think, I don't know which size. I think 14 billion.
Okay.
For code.
Yeah.
I was trying it on the plane back home.
Oh yeah.
To Germany. Yeah. Just, coding away. And I was so impressed.
Listen, every model builder that's dropping open models right now is like cooking pretty hard. Like, I got to shout out the guys at like RC and Prime Intellect and, working with people like Datology and, of course, like Allen Institute for AI, like everyone who's dropping open models is like, in my opinion, whether you're, one landmass or a different landmass, right? Like everyone's contributing in a real way to the progress. And I think it's, there's something to be delighted by from every model. I have never used a single model and walked away saying this is just trash. You know what I mean? Like I always am like, okay, maybe it's not like great for these tasks, but like, look at this thing that I did. That's dope. Even some like weird models, like this is, I'm not trying to roast anybody. So new research has like a bunch of really cool models, but their models for me, maybe sometimes the capabilities aren't where I want them for like, some sets of tasks, but like they're kind of like the funniest models that I've ever talked to. Like they have a very sarcastic sense of humor, which I think like a lot of models just don't care about. And so, like even things that you wouldn't expect, you could be delighted by from a model. Like the people at new research are cooking, man. It's dope. You can see like, having a funny model is good. It's good for the world. Right. So
there's a lot of very interesting stuff on Hugging Face. I also took a deep dive the other day.
Yeah. Hugging Face gets weird. Yeah.
Let's talk finally about one of them, I think, most interesting talking points, especially for us here. Code Gen, I think, is still one of the most important parts for generative AI use cases. What do you see? How do you see open models catching up to that? Because at the moment, I think the frontier is still held by the closed source models.
Hot take here. Okay. Not really, very lukewarm take. But like, open models are very fast a lot of the time, especially like smaller models. So like Nano, right? 30 billion, 3 billion active MOE model. So Nemotron 3 Nano specifically, like it's really fast. And like you can verify that code is correct. Like I think people sleep on that fact, right? Like for like these sweeping, for one-shotting a code base, that like a complex code base and some weird language, right? Like I was gonna curse. I'm very sorry. PG-13. Let's go. So the idea is like if I have a specific function that I need to write, I like Nano could do it 100% of the time. It just might take like 200 generations. But when the model is so small and so fast, like 200 generations is less time than Claude takes, right? Or less time than like Codex takes or whatever. And at the end of the day, if I have a set of tests, like I can get 100% correctness from Nano in less time than some of the frontier models. So when people say catching up, I think they mean like at everything the whole time. But even like you guys, I was very lucky to talk in a session at GTC with David. I think
our VP of
your
AI.
VP of AI. So he's like a pretty chill guy. And like when we're building modern agent systems, like we're not just building based off one model. And so if you have your coding agent and you have the planner and the reasoner and these kinds of things in the frontier model's hands, a lot of the code you can kind of determine complexity, like how complex is this feature, right? And just like you would assign non-complex features to a junior dev, just let Nano rip on it, man. Do I see coding models be able to catch up to the frontier with open 100%? Again, code is a solvable problem. We can literally solve code. It is perhaps going to be difficult and take a long time, and maybe there are some complexities there, but like we can absolutely get to the point where the model always produces correct code.
So let's talk about those complexities, because for a lot of people, it might feel like we're already getting there now. When you look at things like base 44, these type of vibe code applications.
Yeah.
Well, what is the current challenge in the industry?
I don't think we're ready for the slop-pocalypse or whatever that's coming, right? Like, I think Karpathy tweeted about it, something that blew up on Twitter or whatever. But like, the reality is this: this is a necessary transition time, right? In CodeGen's evolution, where every challenge we have now is feeding back into the machine exactly, right? Like you're seeing companies training on vibe coded projects. You're seeing people take that data and learn from it, try to understand how to mitigate some of the weirdness that is vibe coded software, right? And so again, it's just a solvable problem. We see these vibe coded projects taking off and then getting refined over time, right? Like every time this has happened, we start with this kind of gross, complex mess, and then over time, engineers guide it back to even over complex mess. But we have that that state evolution from like absolutely not okay to okay-ish.
Yeah.
And so we can train models to do it better, right? We can train them to do that process. So if I understood the question correctly, I would say like it is a challenge. We got lots of challenges, but we're also literally creating the software to help us solve the challenge at the same time with the same pile of data. So I feel very confident that we're going to get there.
Yeah.
And people like CodeRabbit, not going to shill, but it is your podcast. We're in your house, are working on it, right? Like if all CodeRabbit did, and I know that's not all CodeRabbit does, but if all it did was reduce slop by 10%, right? Like per PR, right? Like over time, we would get to a system that didn't have much slop left, right? And I think that's that there is this competing force in the ecosystem that's trying to hold the vibe coders at bay, or at least help them get to a better place. Means that we'll get to the better place. The same models that are producing slop are the ones we're fighting back. They have equivalent capabilities. It should be possible.
Yeah, I mean, it's an exciting time that we're living in. Where do you see our role as software engineers developing into that?
I don't know. To be honest with you, I think if you had asked me this question in 2025, I would have maybe had a very confident and incorrect answer.
Which was?
Of course, we're necessary.
Yeah.
Of course, we need to understand these systems. Of course, we are integral to the process of writing code. But I think that's because I like writing code. Like, I think it's because I enjoy the flow state of sitting at my keyboard and working through a puzzle and using the tools that I have to do that. Like, I like that, right? And liking something doesn't mean it's like strictly necessary. It's just you like it. I think we remain important in the process because especially right now, AI is not super good at coming up with ideas. AI does lack quote unquote taste, whatever that means to you. It's right. But realistically, I don't know, man. Like, I don't know where we sit in 5 years from now when it comes to software engineering. Are we just managers of teams of agents? Like, are we still literally writing out like if statements? I don't think so, right? But like, I just don't know. Will we achieve the ultimate nerd dream and build a structured syntax that lets us, write scaffolding for projects that looks an awful lot like code, right? But really under the hood is organizing teams of agents to do the work.
Yeah.
So that we're just coding at like a much higher, much more, higher altitude vantage point. Hopefully that would be fire.
I wonder what that multi-screen experience would look like.
Yeah, dude, exactly. I just don't know. I don't know.
Yeah.
I'm hopeful that we'll continue to find ways to make ourselves useful. Humans have needed clever people to work on technical problems since we've existed. We're going to live in a world that's powered by, technology, it seems to me, for the next forever, right? And so we're going to continue to need people who are technically inclined and like working on puzzles. And so we'll find something to do, even if it doesn't look like what it looked like this year or last year or 10 years ago.
Perfectly said. I think that's a beautiful closing thought to close this conversation. Thank you so much, Chris, for taking the time.
Thank you for yapping with me today.
Yeah, no, it's been a pleasure having you on.
We'll see you in the next one.
Thanks for joining in, everyone.